Thanks everyone for coming today. Hopefully you're having a great time at the conference. Yeah? Cool. Give me some energy. Because this talk can be a little scary. All right. Again, everyone's familiar with what recently happened with CrowdStrike. What's interesting, I don't want to talk much about CrowdStrike, but what's interesting is the snowball effect that we had after that, right? Like, of course, it's surprising that people are leaving their services up there from internet anybody to just update the servers. But what's also interesting is when some services were down, how it had a snowball effect on the downstream services. And this is not the first time we've had something like this, right? I'm sure you've heard in a lot of other talks over the conference about several security breaches that have happened over the years. But this is not about security breaches. This is about like APIs going down and how critical APIs have become these days, right? So if APIs are down, here's another example where Bing's API were down and people could not get on to Copilot or ChatGPT or any of these things, right? So you start noticing as a development team or engineering team, you may not realize that the APIs that you're building actually can impact a lot of completely unrelated products because somewhere down they're kind of dependent on your APIs. And I'm just making the case why we need to care about API resiliency and what we can do about it, right? This one I really liked. It's a little dated, but imagine you're locked out of your own car, right? Because the API is down. Like that's quite scary in my opinion. And so, what do you do for resiliency testing of your APIs? Is this something that in your companies you're actively working on? Is this more of an afterthought that someone else's responsibility? They'll take care. My job is just to build the API and shove it down to someone else. Give me some shout outs. Like, what kinds of things do you do for API resiliency testing in your organizations? Monitoring. But isn't that like a little late in the process? Like I'm thinking of like what could we do to get the feedback early on that what API I'm building actually may not be resilient. I've not thought about something from a resiliency point of view. Staging, yeah. So kind of even though we want to shift down, but there are things we want to catch early and give feedback early so that we don't catch that too late and have a surprise, right? So if you ask ChatGPT, these are the kinds of answers this will give, and I'm pretty sure because ChatGPT, it must be true, right? All right, that was supposed to be a joke, but negative functional testing is something that a lot of companies do, where they do things like boundary case analysis. They do basically, if the API is supposed to expect input in certain range, they will try and give inputs outside the range and see if it can handle it gracefully or it just falls over, right? Ends up in a 500 internal server error or things like that. The service may be dependent on some other service, right? And if that dependent service is not responding as you expect, what happens, right? And it's important to kind of think about that from a design consideration of your API and kind of build that out. Of course, chaos engineering or fault injection, that's again something that a lot of companies have started doing that more, more like as a frequent activity to kind of make sure they're catching things early. Performance again becomes very important because under normal load your API might just work fine, but as you start stress testing it, as the hardware starts degrading, how does the API itself performs is important to kind of understand. And of course, from a security point of view, there are a whole bunch of things that you might want to catch early on in your API design itself. And lastly, I think someone brought up that you want to make sure you have good observability built into your API, so you can observe and monitor these things. So here's a whole class of things you can do, and in today's demo, I'm going to kind of focus on two specific things where we're going to leverage the API specification to do these two things for us, right? Without us actually having to write code. And that's kind of in my opinion, the interesting piece. So I'm going to take a example application over here and try and demonstrate how we will be able to achieve those two things that I highlighted from a resiliency point of view. So I have a app which basically talks to an order service. It basically places order on the app, and then the app, when you place an order, you don't provide all the details of the product. You are actually taking a product ID, for example, as part of the order, and then you look up the product details on another service. And on your way back, you might want to log it for analytics reasons onto a Kafka queue or something, right? Again, a very simplified example, but hopefully kind of enough to demonstrate the point of what we can do here. So the system under test here is the order service. That's what we are interested in, testing the resiliency of the order service. And we want to, these are the dependencies that we want to stub out. The reason I'm saying stub out is I want to basically, set up a mock, and I'll be able to simulate things, right? If I don't stub them out, then it's very hard for me to simulate all kinds of possible attacks on them. And finally, obviously, the app itself is a test, but I don't really need an app because we're talking of API. So I'm going to replace the app and basically make API calls to my order service. Clear so far? Okay, let's jump into the live demo. All right, so I have two API specifications here. I'm using REST just to keep it simple. So I have an orders API. This is an open API specification. And the orders API is dependent on the products API. So that's another specification. All this really has is one path /product/ID. And it'll give me back the details of the product that I'm interested in. Okay. The order itself, so when we are placing an order, all it has is a post, and what does it do? Basically, in the post, I'm going to be sending a request of this nature. Right? Here's an example for us to look at. So this is the kind of request that I'm going to be sending. Basically, a discount code is applicable or not. What region are you coming in? I've just tried to simplify it to few regions like Northeast, West. But you could have state-wise taxes and stuff like that. So kind of trying to simulate that. Whether it's a corporate order or not, depending on the taxation, might vary. And then a list of products that you are basically trying to add and quantity of each of them. Right? So this is kind of my API. So what I'm going to do is here I have a simple node application, which is basically just a straightforward thing. So let's quickly run this as just quickly let's run some tests against this and make sure that this is working. And then we'll start simulating all kinds of resiliency tests around it and see how the application holds up and what we can do with it. Okay. So just going to start with npm test. So what this is doing is it's basically spinning up an open source tool that we're using here called Specmatic, which will essentially read the open API specification, generate tests from it, and basically hit the service that is running, right? So it also brings up the application, hits the application. The application depends, the service depends on another service. It's also stubbed out that service. So all of this has happened behind the scenes for you, and we already have the results. Let's quickly look at what just happened here. So we ran 3 tests. 3 tests are successful. Let's look at the example of one of these tests. So what you can see here is an order was posted with this information right here. And successfully the order was created. So 201 response and ID 1 came back, right? As expected, right? This is just the happy path test. I'm just showing to make sure the setup is right. And once the order is created, we are basically fetching the same order and making sure that the order is coming back successfully, right? So just the round trip, everything is good so far. Yeah, everybody with me? This is the basic just setup, right? The good thing is I didn't have to write any of these tests. These were just automatically generated for me. And that's kind of always helpful because developers are too busy with lots of other interesting things they should be focusing on. Okay, so with that change, now what I want to do is I want to simulate a condition where the downstream service, let's say, does not respond in time. Right? The downstream service being the product service does not respond on time. What would happen? How would my application behave? Right? So how would I do that? Let's quickly go here. So there are two examples that are being served out of here. So I'm going to quickly go here to one example. This is the second slash product slash true when you're requesting for that. This is what it's responding back. We just saw that. So I'm going to introduce a delay of 10 seconds. Okay, so all I'm saying is delay in milliseconds, 10,000, so 10 seconds delay. And let me quickly just run this again for us. It's going to take a little bit of time because it's going to wait for that 5 milliseconds timeout, and then 5 seconds timeout, and then there we go. We've got it back. So what just happened, right? We expected, in this particular case, we expected a response to come back, but we got a 500 response back, right? Why did we get a 500 response back? Because the downstream service timed out. This service not handling a timeout and is just ending up with a 500 error, right? An exception is getting thrown, and that's result. So that's fine. And that's why it's saying, hey, you have a 500 response that I got back, but you're not actually handling. It's not specified in your specification that you're supposed to handle a 500, right? So that's why it's saying missing in specification. So what can we do about this? So we've simulated a case where the downstream service is not responding back. Our application is not actually handling it well, right? So what I'm going to do is, first of all, update my specification to make sure that it handles it well. So let's quickly expand this. So what I'm going to do is I'm going to comment this particular thing out, and I'm going to say what I want when this happens is I want you to still go ahead and accept the order, right, and respond back with a 202, which basically is like a partial create, right? So accept the order. Whenever the downstream service is up, you can finish the order, but at least don't like start throwing a 500, right? That's a fair design for this. Yeah. So again, what you'll see is this is API design first. So I'm actually going and making the design change to the API. I'm saying, how do I want the API to behave? I'm updating that. And then, of course, I can run this. It'll fail because it'll expect a 202, but won't get back. So I'm not going to go bore you with those details. What I'm going to do is I'm going to quickly update my code. To say, okay, if the downstream service responds back with a timeout, then essentially, result in a 202 response back. Okay, so just that little change, and let's quickly clear this off and run this. So what do you expect to see now? Any guesses? Let's refresh this, and there we go. So it says basically the 202 now is covered successfully, which means anytime a response for a request for an order, which basically results in a downstream, product ID being 2 is sent, it's going to time out, and then when it times out, it's going to do a partial accept, a 202 accept, and return you back a job ID, which means I'm going to process this at a later point whenever the downstream service is available. So this is a slightly better experience, in my opinion, than just ending up in a 500 error. Would you agree? Yeah. And notice how we are driving all of this through an API and then basically just running these tests automatically for us without us sitting and writing these tests to simulate all of these things for us, right? So this is great, but what we noticed here is that we have a bunch of 400s that are not covered, correct? And this is quite common if you see in a lot of applications, at least I've worked with. People think about all the happy path, the 2xx things, and they actually don't really test the 400 cases, right? You might have a back pressure, right? You might have implemented some kind of, let's say, circuit breaker. How do you test that? How do you make sure your circuit breaker will actually work the way you expect it? this requires you to simulate some actual 400 cases and to make sure that the downstream service, when it's not responding back, we saw that one example, but when you get really bad requests coming in, then you want to make sure that your code can actually handle that effectively, right? Your service can handle that. So what I'm going to do is I'm going to run a set of resiliency tests against this and see, if I send bad input, does it handle correctly? So far, I've been sending only valid inputs to this and making sure it's all working fine. Now let's try and simulate a condition where I'll start sending bad requests to it and seeing if it can actually handle that successfully or not. Okay, so I'm just going to clear this and let's run resiliency tests. All that is doing is basically turning on generative tests, which basically generates all kinds of requests, and you will see that in a minute. A whole bunch of requests are running through. So you'll also start noticing that it's basically putting some positive, negative scenarios in the logs as we go through it. Once it's kind of quickly, it should take a few seconds. Okay. And interesting. That's a lot of tests. Is that a good thing or a bad thing? It's good because you want to make sure, as a developer, you're not going to have the time and patience to try all different permutations out, right? But if you can do that quickly with just a command, that's kind of quite helpful. And it's usually like, a couple of minutes at max, right? So that's worth the investment now rather than a couple of late nights at a later point in time. So it's just kind of quickly running through. Let's make sure that this is done. Okay, I think it runs about 80 some tests. Yeah, there we go. So you'd also notice I've been printing this branch coverage over here. It's kind of slowly improving your branch coverage in terms of what all is covered in your code, right? So it's also giving you that feedback. So let's quickly go here and refresh, and what you will see is a whole bunch of 400s have now started showing up, and you would see a lot of them are failing, right? So let's look at one of them, for example. Here, what I'm doing is I'm basically sending a discount code coupon, but I'm basically making it null. Even though discount code itself is optional, but if I do send the key, then the value has to be present, right? It can't be null. Right? Like these are kinds of cases that usually you're thinking, okay, it's optional, so I'm not really going to worry about it. But if someone sends it and sends null, what happens, right? And that's basically resulting. You expected, the status code to be 4xx, but you got a 201 back, which means your application's really just going ahead and accepting it. So quickly, let's introduce a middleware. Okay, that's basically going to do these validations, and this middleware is also going to work off the OpenAPI specification, so it's going to throw out things for you, so you don't have to wait for it. I'll quickly give it a run. While it's running, we can look at a few more examples in terms of the kinds of things that actually went wrong. Here's another mutation where it's basically made the string null, but it's also the region. It should be south, right? Because that's coming from the enum. And I think it's tried to, no, not this one. Let's see another one where it's mutated the region to something else. So right now you'll see it's doing a whole bunch of iteration on the enums that are possible. But it might, this one is one where it's basically send the region as null, right? So enum, this is an enum, so only 4 possible values, but it's sent it as null, and it still got accepted. There's no validation within the application. So, okay, those tests just ran, so I'm going to refresh, and you will notice that all those 400 tests that were failing, I added the validation, are now passing. Right, so we have all of those 400 cases being handled, right? So again, like it's pretty neat to get this feedback while you're developing and make these fixes so that it becomes you build your APIs to be more resilient, right? So I have 2 minutes left. I think that's pretty much the demo, but I'll quickly summarize. So this is essentially what we're trying to talk about here is, I think Hari, my colleague, also talked about this earlier. We are basically trying to do an API design first approach where, like Dominic highlighted, we put that in Git, a central repo. That's the source of truth. You go through a standard PR process. We do backward compatibility tests on those specifications before even you write any code. I think Hari gave a detailed demo on that. And then, the consumers and the developers, both on the consumers and provider side, can actually use these contract tests to drive their development and make sure that whatever they're doing is actually resilient, right? Like the development is resilient. And so it kind of just talks about how the same thing works in the CI as well. So you have the same consistent experience locally as well as on the CI. And so when you get to integration, you actually don't see any surprises and your path to production is clear, right? So that's kind of CDD, or contract-driven development, in a nutshell, where we are really trying to shift left. We are trying to enhance the developer experience by making sure it is more collaborative, using things like Git, which people are already very familiar with. We're also encouraging people to do parallel development, so the consumer does not need to wait for the provider to provide the service. As soon as the spec is available, both of them can start development in parallel. And finally, APIs are the building blocks, and so you're basically making them resilient by doing all these kinds of boundary case analysis and other kinds of tests that I just demonstrated. So with that, we are hoping that we have a more well-connected world that does not end up in a snowball effect, right? So I think I'm pretty much done. Thank you again. I'll be around for questions later.